So this is going to be about the application of null segregation technology for sex sorting in layer chickens. So first, I'll just talk a little bit about the Hendrix position on gene editing. Overall, as a company, we don't only do poultry, we also do pigs, aquaculture, and other species as well. So currently, Hendrix is not using gene editing in any of its commercial breeding stock. However, we're closely monitoring the technology and investing in research projects to explore its use in specific use cases. So cases where we think that the technology could really make a step change in terms of achieving our goals. So we're not planning on applying it to traits where traditional genetic selection can be used. Traditional genetic selection is a really, really powerful tool. As mentioned in some of the other talks previously, when you take on a gene editing program, you're going to have some lag and things like that as you start to introduce the trait into your higher breeding line. And so traits where we could just use genetic selection, we don't feel like it's worth it to try to use gene editing when we could just use genetic selection, so we don't have that lag. However, the research is focused on traits that are related to animal health and welfare, not increased production specifically for Hendrix, but I know that there's other programs that are looking at that. But yeah, traits where we feel like we can't reach it through natural or through traditional genetic selection, but also traits that are impacting the health and the welfare of the animals that are really critical for moving forward in the business. So this project was kicked off a few years ago, and it's a collaborative project between Hendrix Genetics and CSIRO down in Australia. And so it's a partnership to study innovative sex sorting technology to test if we can create innovative systems for sex sorting at point of lay in the poultry industry. So this is our collaborative partners, CSIRO. So I used to work here at CSIRO for 7 years. So I'm really, really familiar with the team, and some of the people that are on the team, like Mark Tizard, are also part of this conference here today. And so it's down at the Australian Animal Health Laboratory, which is also the Center for Disease Preparedness these days, within the chicken genome engineering team there. So a little bit about the problem. So what is the problem that we're looking to have a solution for? So basically, in the poultry layer industry, you have the culling of male chicks. Males don't lay eggs. That's pretty obvious. And like in some other industries, you've got broilers and you've got layers. So you've got meat producing animals and you've got egg producing animals. And so the males coming from the egg producing animals are not actually efficient at producing meat, and so it's not economically sustainable or really like environmentally sustainable to try to raise them for meat production, because they're just not very good at that. And so current industry standard is to hatch all of the chicks and then sort them, sex sorting them after they hatch, and then cull all the males that come out. And so it's a wasteful situation, obviously. It's really labor intensive. It's actually very difficult to sex a chick at day 1 of age. And so these are really, really highly skilled people that are doing it at really, really fast speeds. And so, it's people that are doing it. So it's really labor intensive and costly. It's also currently not allowed in certain jurisdictions, especially in Europe. And so there's also discussions around other jurisdictions like the US and things like that, introducing laws in. And so the industry really wants to get ahead of this issue. They recognize that it's an issue, and they're trying to implement technologies to try to get away from this practice. And currently it's estimated that 7 billion male chicks are culled every year globally through this practice. And so it's a big issue. It's a big waste of resources. It's not good environmentally. It's obviously not good for the welfare of the animals. And so we want to move on from that practice. So pathways to improving the welfare and a potential solution. So current industry practice, hatch the chicks, sort them at day of hatch. New technologies that are especially coming out in Europe, where some of these practices have been outlawed, are looking at incubating the embryos to, say, day 5, day 9, and then taking a sample, sorting the males from the females, and then at day 5 to day 9 of embryo development, and then discarding the males then. So this is a pretty costly solution. It also means that you're pulling all your eggs out of incubation, taking a sample and then putting them back in, and that can have a lot of impacts on viability of the embryos as they move along. And so while it's definitely a step forward and certainly is improving the situation, it's costly and has other production implications as well. So our solution is marker sorted at point of lay, and so it's actually prior to incubation, enabling sorting of males from females right after the egg is laid and before it goes into incubation, and so you have no incubation of the embryo. And so how would this be done? So detection at point of lay would be achieved by incorporating a detectable marker on the male sex-determining chromosome. And so chickens are a little different than humans in that it's actually a female has a Z and a W chromosome as opposed to like XX in humans. And then the male has a ZZ or a ZZ as opposed to XY in males. And so what this means is if that female has a marked Z chromosome, her male offspring will always inherit that because her female offspring are always going to inherit her W chromosome, if that makes sense. So it's the female is basically the sex determining one of that mating. And so all of her female offspring will inherently inherit her W, and all of her male offspring have to inherit her Z. So we'll look at it across like this if this makes a little bit more sense. And so the female is producing ovum, half of them have a Z and half of them have a W. The male is producing sperm, all of his sperm have Zs, and so all the female ovum that have a W end up as females. All the female ovums that have a Z end up as males. And so if we're able to mark that Z in that female, then we could sort these eggs at point of lay. So yeah, so if we're able to mark that, then it gives us a way to be able to have a non-invasive method for pulling those eggs out. And that also means that the females would be null segregants. What that means is that they've been segregated away from the gene edit. So because they're inheriting the W from the female, from the mother hen, and that W doesn't have an edit on it, and the male that has been mated with doesn't have any edits either, that means that results in females and null segregant because it doesn't actually contain any of the edits. So what would this look like in practice? So chickens are bred through a pyramid, and so you have a four-way cross when you are breeding chickens. And so up at the top, you've got your pure line chickens, and so you've got 4 lines of pure line chickens, and then you basically crossmate these down to the end to get your 4-way cross, and so that's your production level chicken, and so that's the chickens that are actually out on farms laying eggs, and then the eggs are going to the grocery store. And so to enable this project, we would need to establish a flock in the C line that would be double marked males and single marked females that would allow for breeding of pure double type males. That would be in the grandparent line. And then the grandparent line would be bred to produce those single marked females that we discussed before, which would then be bred with just wild type AB males, which would produce null segregant females that don't contain the edit, and then marked males that would be able to pull out at point of lay. And also because of this breeding pyramid, it means that you actually don't have to produce that many animals at the top, because every time you go down through a generation, you're expanding out the flock numbers. And so once that top line is established and created as a pure line, then you can simply breed as you normally would for that trait. And so that looks at that, the pyramid, basically in terms of numbers and also marker integration. So you integrate the marker here at the very top of your pyramid. You've got genetic improvement and pedigree selection. So once you actually establish that flock, then you just continue with your improvement and pedigree selection as you normally would. You breed down to your great-grandparents, grandparent, and parent stock. Within all of these lines, you have the marker present in those breeding animals. However, once you get to the commercial layers, those are the null segregants, and so they no longer have the marker present. And so the marker isn't present in your commercial layers. It's not present in the eggs that are coming from those commercial layers, and so it's not actually going to the consumer either. And so the marker is in the system, in the upper part of the breeding system, but it's not actually going down to the commercial levels or actually in the product that's produced. And so exploring pathways to implementation, obviously, there's a lot of technical things that are going on. It's currently a research project, and there's a lot of technical developments that we're making in the project. I won't really harp on those right now. But a big component of the project is also understanding the regulatory pathway. We're looking at, we're exploring implementation in Australia, especially because the group is based in CSIRO. And it makes a good test case to think about how we would actually work with all the different the markets and the agencies and things like that. We're also obviously, in a broader perspective outside of the research project, thinking about potential markets in places like North America and South America. And we're in a really good spot. CSIRO's already conducted research and looking into things like social acceptance in Australia of sex sorting technology in Australian context. So it makes a really good test bed to think about how we're proceeding. But like I said, we're also looking at other markets as well. So in that Australian perspective, these are, some interactions that we've had. And so obviously, we're looking down here at just like the actual production line. So you've got the global genetics companies. So obviously this is Hendrix in this case. Then you've got national breeders. And so in some cases, Hendrix would breed, their pure lines, their grandparents and their parent stock. But sometimes there's other breeders that are going to be breeding parent stock, partnered with Hendrix Genetics. And so we're talking with national breeders just about the project and, what they like about it, what they don't like about it, what their concerns are. Then you've got actual egg producers, so producers that have the commercial line animals that are the hens that produce the eggs. And so we're also talking with them. We've had a lot of discussions with supermarkets and things like that just to get their feel for, for them, male culling is a really big industry issue. And so they'd really like to see a solution to it, but just to feel them out in terms of how they feel about this solution, how they think it would fit in their through chain, and then, of course, consumers at the end. And as I said, CSIRO's had specific interactions and done specific studies in terms of consumer attitudes in this project. But sitting outside of that, you've got regulation and policy. And so that's obviously critical. There is no supermarket, there's no egg consumers if you're not engaging with the regulation and making sure that the process is approved. And so in that space, we've got the Office of Gene Technology Regulation, OGTR, and FSANZ, which is Food Standards Australia and New Zealand. And so there's been a lot of interaction with both of those groups in terms of the technology and possible rollout. And then you also have other groups that are going to impact, social acceptance and, how it's rolled out and how it's perceived. So things like animal welfare NGOs like the RSPCA, obviously they're a group that's really concerned about current practices in male culling. And so getting them to understand what the technology is, hearing them out in terms of what their concerns are and what their positives are is really important as the project develops. And, we've had interactions with other groups as well. And so it's just really important to take on those outside perspectives because, as a project, it can be really technical and you're thinking about implementation and things like that, but you have to broaden the scope in terms of who you're talking to and who, to hear concerns, especially from the public and from other organizations that are really focused on animal welfare. What are their concerns? What would they like to see as the project develops? And so that's really important. And also, social media, consumer interest groups. There's obviously a lot of groups that you can interact with in this. And so we're currently in the process of doing that in Australia. And so an example coming from Australia, so the technology, as I said, is based on this null segregant process. So at the commercial breeding line, those females have been segregated away from the edit, and so they don't actually contain the edit themselves. And so this is a widely accepted process in plant breeding. However, not all regulatory agencies have taken a stance on how they feel about null segregation as, a process for separating an edited animal from a non-edited animal. Luckily, in Australia and New Zealand, they've clarified those, and so they will recognize that process. And so this is just an example from Fazan's, and so food equivalent from a null segregant, or food from a null segregant only requires equivalence test, basically just some simple analysis to show that, the eggs coming from this are the same as eggs coming from other things. And so that's really great that they can recognize that, the final product that's coming out of this process is not actually edited and shouldn't have, tons and tons of regulation, because it should be the exact same egg as a conventional chicken is laying. And so you can see that actually here in the food standards. They showed this. They did a review of the program recently, and they showed this as an example of what null segregant technology is and what it can do. And so they're really well engaged with the project, which is really nice to see. So other jurisdictions, obviously, as I said, the research program is taking place in Australia, and so there's a lot of focus on Australia right now, which makes a lot of sense as most of the team is based there, but Australia is obviously not the main poultry market in the world. And so what are we doing in the other spaces? So not all regulatory systems recognize null segregation as a way to separate edited from non-edited progeny. Some of them, just haven't said anything either way about it, maybe have never been proposed with a project. Some of them, the way that the regulations are written, basically it says, all progeny of an edited animal or a GMO animal is considered edited, whether they carry the edit or not. And so looking at different jurisdictions will likely have slightly different pathways in them. And so for us, that's going to be something that we're navigating as we move forward with the project in terms of the data that we collect and how we present it. Of course, as I said, birds high up in the breeding pyramid will contain the edit and will need to be kept accordingly. Those pure line birds, the grandparent birds, the parent birds, they all, not all of them, but within that C line, they contain the edit. And so we'll need to consider that, from a regulatory perspective, in terms of bird health, and different production specifications, but then also in terms of biosecurity, the facilities that they're kept in, the tracking of the animals, all of that sort of thing, because they will contain the edit. And so we expect them to be regulated as such. However, because they're higher level breeding stock birds are already kept in facilities with strict biocontainment due to the value that the birds present. And so, we don't see this as being a huge hurdle because, birds already have pretty strict biosecurity, and the higher up the pyramid you go, the stricter it is. And so there's already, great protocols in place for biocontainment, for, animal welfare, monitoring birds, things like that. And so I think a lot of the structures are already in place to be able to meet our regulatory requirements. Trade, obviously there's a lot of questions around trade. So, one thing to consider specifically with this project is, if they're approved in one jurisdiction and considered not edited as the null segregant females, can those be freely traded? If, say, Australia approves them, not that you can trade out of Australia because of their biosecurity laws, but just say they're approved in Australia, and they consider those females that come out of the process as just conventional females because of the null segregation process. Can those animals be sold on to another country and just be considered conventional animals? If they're not considered conventional animals, how would they be tracked? Again, because they are null segregants, they don't actually contain the edit, and so how you would track them is a really big question, because they should be no different than conventional animals. And then further from that, the products that are coming from these, would the egg products coming from these null segregant hens require further labeling in some jurisdictions? How would this be implemented? How would it be tracked? So those are some big questions that still sit around, and I think, are true for a lot of different projects, but especially true for this one because of that null segregant and whether that will be accepted or not accepted in certain jurisdictions. And so it adds a sticky point because you can't really track those hens don't contain the edit, and so it makes it much more difficult to track them, and do you actually need to track them? So those are some questions that, we think about as the project progresses. So conclusions, I know I didn't really talk about the actual research a lot. So as you can imagine, it's fine to put up a picture and be like, look, it just is passed along from generation to generation. Obviously, the nuts and bolts of making that work efficiently and well is a lot more technical and a lot more difficult, but the research is going really well. So we're really pleased with that, but there's still a lot more work to be done. And in general, like our experience has been that gene editing projects should consider not only the technical milestones, but also regulatory, societal, and animal welfare implications of the projects as they develop. And that's it.